So there's a special formula that comes about when you do something called continuous compounding. So to explain where this comes from and what this is, let's imagine we take $1. Let's say that the interest rate is 100%. So it doubles every year. And then we're going to start compounding it. But we're going to compound it at different rates. So if we do it monthly, we would take a $1, we'd do 1 plus, we'd take the 100%, which is 1, and put it over 12, and raise it to the 12 times 1. At the end of that first year, you would get $2.61. And then I'm going to write the rest of the decimals that you would see here. So it's 2.6135, and so on. So we might start by going daily. This would be 1 over, and we change only the compounding. So this would just be 365. After we do that, we would get $2.71. And there are some fractions behind it. 4, 5, 6, 7, dot, dot, dot. So from going monthly to daily, we get an extra 10 cents. Okay, we could do even better. What if we did it hourly? Be 1 and 1 plus 1 over. Now I have to take 365 and multiply by 24 to figure out how many hours are in a year. It's 8,760. And when I crunch that, I'm going to get $2.71. Okay, now if you look at the decimals behind it, they are different. But the difference between daily and hourly when it comes to money is not different. If we do it every second, it's the same story. So we're still going to start off with $2.71, but it will go 82828 dot 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 dot. And so the difference here was 10 cents. But then when we went here, it was 0 cents. And there still was a change. It's just the change is so small that that's why often banks will just stop at daily. Now, if we do this every second and then split it even further and do it continuously so that we're compounding better than secondly, we're compounding all the time, every instant, what we get is this number, 2.7182818 dot 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 dot. Now this number turns out to be a lot like pi. The digits never repeat. And this number comes up so often that we call this the number e. It has a special variable. Okay? And when we do this continuous compounding, this is the formula we use. Total equals P e to the RT. So this is total. This is principal. This e is actually like 2.718 blah blah blah, but you should have an e button on your calculator. This r is your rate, and this is your time. So for example, if you're going to do $5,000 continuously compounded for 3% for 2 years, this is how you would set it up. The total would be 5,000 e times e to the 0.03 times 2. You should double check to see that your calculator gets the same thing we do. When I plug it all in, I get an answer of 5,309.18. Okay, now one thing to be to notice here is that the interest, you don't add 1 to it this time. So for this formula, you would just put the rate up there, multiplied by the time, up in that exponent.